This video will be about probability. There's a lot of situations you can apply probability to. For example, you could flip a coin, you could toss a number cube, which is the same thing as a dice. You could toss two number cubes, you could draw stuff from a bag, you could collect and analyze data. We learned methods of collecting data. You can use a spinner. There's lots and lots of different situations that you could apply probability to. But with all those situations, it comes down to this fraction of what you want to happen over the total ways something can happen. So for example, when you flip a coin, there's two sides to a coin. You can get a heads or a tails. That's the total ways you can flip a coin. If you want to get heads, there's only one out of two ways to get heads. So with our probabilities, there's three ways to represent them. A simplified fraction, a decimal, so you could plug this into a calculator and do 1 divided by 2, which is 0.5, or a percent. To get a percent, you take your decimal and you always multiply by 100 because all percents are out of 100. So 0.5 times 100 is 50%. So there's two types of probability, experimental and theoretical. Theoretical is when you just analyze the situation without actually performing any trials of it. So like flipping a coin, we said there were two total ways, and if we wanted heads, there's one out of two ways. That's your theoretical probability. Experimental would be actually flipping the coin. Let's say we flip a coin 10 times, and these are the results. Heads, tails, tails, heads, 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 tails, heads, 7, 8, 9, 10. So we flipped the coin 10 times, recorded what we got every time. That's our experiment. So the probability, let's say we wanted the probability of heads with this information. We have 1, 2, 3, 4, 5, 6 times we got heads. That's what we wanted to happen was heads. And then we said there were 10 total. So 6 out of 10. Now we did say our fractions need to be simplified, and this is not simplified. Anytime you have a fraction, decide what divides into both the top and into the bottom. So one number that divides into 6 and into 10. So 2 would divide into 6 and 2 would divide into 10, which would give you 3 over 5. If you're not sure that's simplified, check again. Is there anything that divides into 3 and also into 5? Well, the only option now is 1, and that's useless to us. So 3 over 5 is our simplified fraction. So let's say we do our 10 trials and we want to know what's going to happen on the 11th trial. What's the probability of getting tails for our 11th option? Well, since these are all independent, doing one doesn't affect what happens next. It actually doesn't change your theoretical probability. All of these have no impact on the theoretical probability of what comes next. The next one, to get tails, would still be a probability of 1/2. Or 50%. It didn't matter that we'd flipped a coin a whole bunch of times and we'd only gotten 4 before, because when you flip a coin, flipping a coin before that doesn't impact what happens. So let's look at a standard number cube. So a number cube is a die, and they normally have 6 sides. There are other types of die, but most of the time they'll use the standard and they'll specify on a question how many sides it has. So 6-sided number cube, what's the probability of rolling a 1? Well, on the number cube there is only one side that contains a 1. So that's what we want to happen. There's one way to get a 1, and there's 6 total sides. We can't see 3 of them because we're drawing on a two-dimensional surface, but there are 6 sides. So 1 out of 6, which is as simplified as it can be. They can switch that up and give you like a grouping of numbers. Even numbers, so even numbers are 2, 4, 6, and we can keep going, except on a number cube we don't have any numbers higher than 6. So 2, 4, and 6, that's 3 total ways to get what we want, 3 even numbers, and 6 total numbers on the number cube. Now again, if we want this to be reduced, we say what divides into 3 and into 6. Well, both of those divide by 3, so 3 divided by 3 is 1, and 6 divided by 3 is 2. Next, they can take it up a notch and have 2 groups. They could say an even number or a prime number. So even numbers, we already stated, those are 2, 4, and 6. Prime numbers are numbers that only have factors of 1 and the number itself. So like 2 is a prime number because only 2 times 1 can multiply to be 2. 3 is prime because only 3 times 1 multiplies to be 3. 4 is not prime because 1 times 4 works, but 2 times 2 also works. Has to only be 1 and the number itself. And then 5 is also prime. 1 is not considered to be prime. So the only problem is we have a duplicate, this 2. We do not need to count it twice when we use this word or. Rolling a 2 that's an even number, that is the same as rolling a 2 that's a prime number. So total, we have 1, 2, 3, 4, 5 ways to get an even or a prime number, and 6 total sides of the number cube. Then we can switch it up even further and roll 2 number cubes at once. So if we have 2 number cubes, what's the probability of rolling a 1 on the first number cube and rolling a 5 on the second number cube? So rolling a 1, there's only 1 possibility, and rolling a 5, there's only 1 possibility. But what do we do when there's 2 dice going? So this goes back to that counting principle we learned. On the first dice, there were 6 total ways to roll that first number cube. On the second one, there's also 6 total ways to roll that second number cube. So total ways to roll 2 number cubes is 36 possible ways. So if you have 1 way on the first cube and 1 way on the second, when they are 2 separate things, we multiply those together. 1 times 1. So really it's like we're multiplying the probabilities together. 1 out of 6 times 1 out of 6. 1 way to get a 1, 1 way to get a 5 out of 6 ways on each number cube is 1 out of 36. So anytime you have 2 events and they're independent, they don't impact each other, rolling the first cube will not affect what you get when you roll the second cube. You multiply those 2 probabilities together. So last way to switch it up, probability of rolling a sum of 8. So this one's different. Instead of looking at it as 2 different things, we have to look at it as 1 thing. We do still know there's 36 total possible ways, but we need to figure out, well, how many ways could we get a sum of 8? So looking at our number cube, if we rolled a 1 on the first one, there is nothing on our second number cube that could add up to be 8. The highest number is 6. That only takes us to 7. That doesn't work. Well, how about a 2? 2 plus 6 does give us an 8. So there is 1 way to roll an 8. And if we do the opposite, if we roll a 6 and then a 2, we still get an 8. So 2 plus 6 and 6 plus 2, those are 2 different options. So then we look at 3. 3 can add to 5, and 5 can add to 3. So there's 2 more options. Then we look at 4. 4 can add to 4. But if we flip it, it just repeats, and we don't need that repeated option. So we have 1, 2, 3, 4, 5 ways to get a sum of 8. So 5 out of 36. Next, let's look at the situation of drawing from a bag. So let's say we have a bag that has 13 red marbles, 15 blue marbles, and 12 black marbles. So they didn't tell us the total, but we can find it pretty easily by adding them all together. 13 plus 15 plus 12 is 40. So there's 40 total marbles. So probability of picking a blue. We have 15 blue marbles out of the 40 total, and we do need to reduce this fraction. Both of these can divide by 5. So 15 divided by 5 is 3, 40 divided by 5 is 8. Okay, next option, probability of picking a red or black. When we say the word or, we're considering both together. So there are 13 red and 12 black. We're going to add those together. 13 plus 12 is 25. And then we can use that to find our probability. We have 25 ways out of 40. It doesn't matter if I pick red or if I pick black, so we can just add them all together. This will also reduce. It can also divide by 5, which is 5 out of 8. So when we're working on drawing things from a bag, we can draw more than once, and there's a difference between replacing an item and not replacing an item. So when we pick these objects, they are going to be independent. Picking one is going to be separate from picking the second. So probability of picking red is the first thing that's going to happen, the first event. Well, picking red, there are 13 red marbles out of the 40 marbles total. If we put the red marble back in the bag, it's not going to affect the total. We will still have 40 marbles. So we still have 40, and we're going to pick black now. So we have 12 black marbles. So let's say we want to find this one as a decimal. If we plug this all into a calculator, we get 0.0975. If they say to put this to the nearest 10,000th, we'd be done. If they said, say, the nearest 100th, we would look at this 9. Next to it is a 7, so the 9 is going to round up and push it to be a 0.10. 7 would round the 9 up to a 10, and then 1 plus 0 gives us the 1. So then let's look at not replacing it. If we pick red, it's still 13 out of 40. That doesn't change. When we go to pick the black marble, though, our total has been changed. Now there's no longer 40 marbles. We've taken one out, so there's only 39 marbles left. So when we pick the black, it's 12 out of 39. If we plug this into a calculator, we get exactly 0.1. So the two probabilities are pretty close, and if we rounded this probability, it looks like they're exactly the same. But if we don't round, we see, well, they're just a little bit different. So there's a difference between replacing and not replacing an object. So let's go through one more type of situation. Let's say we've collected some data. We've used good sampling methods, and actually for this one, we've just collected data from the entire student population of a school. We found out how many freshmen, sophomores, juniors, and seniors there are, and which ones are male and which ones are female. So we can ask a couple questions about this, again, this entire table. For example, I could say, what's the probability of picking a female freshman out of the entire student body? So female and freshman is 165. Those together consist of all the females who are also freshmen. The total student body is 1,178. If we divide these two, 165 divided by 1178, that gives us our probability, what we wanted, over the total amount. So let's say we do this as a percent. We do have to get the decimal first. It's 0.140. So if we multiply that by 100, it gives you 14.0%. So let's take a similar question. Instead of asking what would happen if we picked one student out of the entire population who is both a female and a freshman, what if we said, what's the probability of picking a female student from the freshman class? So this time we are not using the entire student population. We're still using the female freshman number, but this time, since we're only picking her from the freshman class, we're only using the 303. So 165 divided by 303 is 0.544, and there's a lot more to the decimal, but I'm only writing out a few. Let's round this to the nearest hundredth, so 0.54 only, times 100 is 54%. So let's just do one more. Let's say we want to pick from the junior and senior class and find one student who is a male. So we're limiting only to these two lines. We're picking from juniors and seniors, and we want to find the probability of picking a male. So the male students, we have 152 and 143. We have to add those together ourselves. Since there are two, we need to find the total amount of males, 295. We also need the total amount of juniors and seniors together. So that would be the 330 plus the 302. So this one we have to do a little bit of computation before we can then do the probability. So total amount of juniors and seniors is 632. So we wanted a male student out of the juniors and seniors total population. So then we can plug this into a calculator. We get 0.466. We're going to round to the nearest hundredth again, which is 0.47. And then you have to multiply 100 to make it a percent, which is 47%. So you do have to be a little bit flexible with the probability. There are a lot of various situations that we can use, but that covers most of the types of situations you will see. So that concludes our discussion on probability.